Hey, what's up, guys? Yeah. So, uh, right. So I think previous video that I talked about Black-Scholes equation, right? So, uh, we proved that if someone can use a Black-Scholes equation, then you can use a change of variable. So you can you can prove that the Black-Scholes equation is equivalent to the Heat equation. Okay. So Heat equation then this is easy to solve, right? If you know about engineering mathematics. Basically, there is an idea of Heat kernel. So also in this video that I will just make a quick video that about the Heat kernel. Okay, and just rebuild this theory. Okay. Uh, okay. So let's start, and hope you guys subscribe to my channel. So the Heat equation looks like this, right? So uxx, so ut is basically partial t, partial u. Yeah, the uxx is the second derivative. Okay, so and the condition is that our initial ux0 is f of x. Okay, so the very amazing results is that from these two, then you're already able to solve the general uxt, right? So the idea is that there is a Green's function, but the answer will be just this. F of s hx minus sds, and this it's called ht. So ht is the so-called Heat kernel. Okay, so it's 4 pi kt exponential minus x square divided by 4 kt. Oh, by the way, t greater than 0. Okay, so this guy is called Heat kernel. Okay, so this is called obvious. This is if you know about some basic engineering mathematics, this is convolution, right? So convolution. Okay, so idea is that this guy, right, this function is the Green's, actually this Heat kernel is a Green's function of this PDE, right? So the solution will just be your solution convolution with the Green's function. Okay, so the rest of the video just prove this. Yeah, so okay, so the idea is first is using the Fourier transform. And if you know, I mean, there are a lot of kind of Fourier transform. Okay, but now we use a continuous version. But if you're interested, then you can check out. There's a discrete version that, or like, yeah, there's an analytic number theory, which is like continuous one. But that's talking about a discrete one. Okay. So, in order to solve this UTT, right? So it's UT equals to KUXX. The idea is that we try to write it as Fourier transformation, right? So, yeah, I think. Okay. So, yeah, let's do this. So let's write u, right? Uxt. We transform of x, right? So we transform it as let's call this uh u of omega and t exponential negative I omega x d omega. Okay. Okay, so this is Fourier transform. Let me just call this u hat. Okay. Okay, and then we just plug this into this. Okay. So right, so we get this t I omega x d omega equals to k. Okay, so if you do x derivative, then this gives you I omega square u hat d omega. Okay. And okay, and this gives you also okay, since this is a there's some rigorous proof, but basically this you can show that this is ut hat equals to minus k omega square u hat. Okay, and okay, then this tell you what? This tell you that you can easily solve, right? U hat is basically the constant times exponential minus like k omega square t. Okay, so this is omega t, and we put t equals 0, right? We put if we put t equals 0, then we know that u hat must be f hat, right? By definition, at the beginning u equals f, right? So this is f hat of x. Is this. Also, f hat is omega. Okay. So then the rest is just inverse Fourier transform. Okay. So the idea is that we already know this. We already know this is this, right? And so the rest is trivial, that we just need to inverse Fourier transform of u hat. And very simple record is that if you convolution f and g and do the Fourier transform, then it will be the f hat omega and the g hat omega. So it will be the just a Fourier transformation of maybe there's a 1 over 2 pi or something, but when you do the convolution, then the results, the Fourier transformation will just be the product of the Fourier transform. Okay. Okay, so yeah, so this is f, right? This is just f, and what is this? So we want to find basically we want to find a function. Let's call it g, such that the g hat it transforms this. Okay, and the results I'm saying is that the results will be one can check. If you go to gtx equals to square root of pi divided by kt exponential minus x squared divided by 4kt, then this gt hat will be just this. Okay, so the proof is very simple. You just brute force calculated. 4kt, right? Exponential I omega x. Okay, tx 0 infinity to negative infinity to infinity. And this one that one can just brute force compute using the following formula. Exponential ax plus bx dx will be infinity to infinity will be square root of pi divided by a squared divided by a, and the exponential minus b squared divided by 4a. Okay, so brute force compute will show this is exponential negative k omega squared t. Okay, so yeah, so we have the answer. So now we have uxt, and there is a convention 2 pi will be the f of s, and the convolution with g. So f convolution with g is g of t x minus s ds. So it'll be 1 divided by 2 pi, infinity to infinity, f of s, and the square root of pi kt is equal to negative x minus x squared divided by 4 kt. Yes, okay. And combine this 1 divided by 2 by 2 this, you get infinity to negative infinity f of s, and then you get 1 over 4 pi kt is equal to negative minus x as s squared divided by 4 kt ds. Okay, so this is ht of x minus s, as we just proved. Okay, so this guy is a Hie kernel. By the way, you can change this to be omega, but I use s. Okay, so once we have this, then in the next video that we can just using this Hie kernel method and directly solve the Black-Scholes equation, so that you know how to derive the exact solution of the Black-Scholes equation using the Hie kernel method. See you guys next videos.